Hello people, let's know about a very interesting type of thing that is a torque converter. Okay, so it is an application of hydraulic coupling that we have already studied about in our previous video. So what does a torque converter do? So a torque converter is basically a coupling that connects two shafts. Okay, uh, a driven shaft and a driver shaft. Okay, so it connects the two shafts and transmits power from one shaft to another. Now let's move ahead and know something more about it. So this type of torque converter is generally used in automatic transmission vehicles. Okay, the vehicles which uses automatic transmission, there these torque converters are implemented. Okay, so what is the basic function of this torque converter is to convert torque or to multiply torque. Now we will know about it, that why these things are called torque converter further. Okay, let's know about the components in this torque converter. Here is a driver shaft, a driven shaft, and a whole casing, a whole housing in which there is an impeller and a turbine. Okay, we know about it. And this whole specific arrangement without the reactor, there is one more thing, reactor in between pump and the turbine. Okay, there is a reactor. Now what is the function of reactor, I will tell about it to you. But without the reactor, the whole assembly is specifically a fluid flywheel. Okay, it acts as a fluid flywheel because it stores energy and gives to the driver shaft whenever necessary. Now if we if we attach a reactor with this assembly, then it becomes a torque converter. Okay, now what it is, a reactor, what does a reactor do? It sends fluid back to impeller. Now see it carefully. When the fluid travels from this way to this turbine, and what does the reactor do, that it transfer the water back to the impeller. Okay, so it sends the fluid back efficiently to the impeller from the turbine. After it does some work, after the fluid does work on the turbine, the reactor returns the water back or the fluid back to the impeller efficiently. Okay, so this is the basic function of a reactor, and the reactor is connected to a one-way clutch. It means that the reactor can move only in one direction. Okay, we will know about it further, that the reactor can rotate in only one direction. It is connected to a one-way clutch, like what happens in a one-way valve. The water or anything can move only in one direction. Same thing happens here. The reactor can rotate only in one direction, and if it tries to move in another direction, it gets locked. Okay, so what happens, slippage is allowed in between the pump and turbine due to liquid, as the working fluid is, as the working thing is liquid here, so slipping can occur in between the pump and turbine. And what is the benefit? Now assume that you are driving a vehicle on a road, and the vehicle is you are accelerating it, and suddenly you applied brake without deaccelerating the vehicle or without applying the clutch. What will happen? Okay, the vehicle will stop, but there are chances of mechanical failure, because at the same time you are accelerating the vehicle and you are applying the brake, so the brake may fail or any mechanical component of the system may fail. Okay, so this thing is prevented here, because in automatic transmission, whenever you apply brake, even without applying the clutch, okay, or without deaccelerating the vehicle, you can make your vehicle stop and there will be no mechanical failure. Okay, now why? Because slipping is allowed in between pump and turbine, because the working substance is liquid here, and liquid can slip from the turbine back. Okay, it means it imparts energy to the blades of the turbine, but it will not rotate. It will provide some reaction to the water or the working fluid, and the water will come back. Okay, but it doesn't happen in a mechanical clutch. Okay, it is a modification of clutch actually. If in clutch we suddenly apply brake, okay, while the vehicle is moving, then what will happen? There are mechanical failure will occur. Definitely there will be a mechanical failure if we suddenly apply brake when the clutch is attached. Okay, now this doesn't happen here. Okay, now let's move ahead and know something more about it. Okay, so if this is turbine and this is pump, okay, now you can see that I have shifted the positions of turbine and pump. Turbine I have put here and pump is here, and this is actually what happens in actual engine. Okay, the pump is connected to the transmission side and the turbine is connected to the engine side from where power is coming. Now why this happens, we will know about it further. Okay, but where we studied previously, the pump was here this side and the turbine was this side. But the answer to this question is originating from mechanical point of view. We will know about it further, that while turbine is put here and pump is here. Okay, so what happens at low speed, the water from or the liquid from here will approximately come actually to the reactor. Okay, so what will happen, the water will try to lift the reactor up in the upward direction, but as I told you that it is a one-way clutch, so the reactor will not move in that direction because it is only it is made only to move in this direction. Okay, this outward and this direction, it cannot move in reverse direction. So what will happen when water strikes it, the water will get diverted and it will move in this direction. So okay, as the pump is already moving in this direction, and due to the motion of pump, the water is being transferred to the turbine, and the turbine is moving due to the impartation of kinetic energy of the fluid that is coming from pump. Okay, the fluid firstly comes from the pump to the turbine and imparts some energy to it. Okay, the turbine then rotates, and what happens, the water then moves back. The water moves and it cannot rotate the reactor in opposite direction. So what will happen, the water will get diverted and it will move in this direction, and it will impart some additional torque to the pump. Okay, that's why the pump is known as that's why this whole arrangement is known as torque converter or torque multiplier, because an additional torque, it means we are utilizing the lost power, the power that was going to be lost. We are utilizing that power in improving the torque efficiency or improving the speed of the pump. Okay, now what happens at low speed, I have told you that water enters the turbine axially, water enters the pump axially. The water will enter axially to the pump, but at high speed, what will happen when the turbine is rotating at very high speed, then the direction of the water from the turbine will be in this direction. Okay, because relative motion, there will be a relative motion between the turbine and the water will be moving in this direction. So what will happen, that as the water moves in this direction, the torque conversion or the torque that was being imparted, the additional torque that was being given to the pump, that will cease out. Okay, that will be the maximum torque conversion or the torque multiplication that the pump can take at that time when the turbine attains high speed, and at that time the turbine will attain a speed of around 90% of that of the pump, and that is a very fine thing that we attain such a high speed to the pump. Okay, so okay, let's move ahead and know something more about it. Okay, so in modern torque converters, what happens, during normal operation we lock the turbine and pump mechanically with a lock-up clutch. Now why this? Because in previous case we were attaining a velocity or an efficiency of about 90%, but here if you mechanically lock them up, then the turbine will rotate with the same speed as the pump is rotating. Okay, but it will not provide us the facility of the torque conversion here, but this is done, the lockup clutch is used when we are on a highway or on a long trip, then we can use this. We can get same velocity as that of the pump and can avoid the hydraulic losses. But when we are in another operation, like we are in a traffic area, or we are in some another area, then we can use this torque converter originally in its original form, and then it will be beneficial that I have told you about, that whenever we apply, when we apply the brake, the there will not be any mechanical failure and the vehicle will get stopped. Okay. And when when the engine is still running, and I have now, the pump is here, it is installed here, and the turbine is installed here. And what happens, it is connected with a casing. The pump is connected to the flywheel with a casing, due to which when the flywheel rotates, the pump rotates too. Okay. So the pump rotates, and the pump then imparts velocity to the kinetic energy to the fluid, and the fluid then imparts energy to the turbine, due to which turbine rotates. Now we will know in our next video that why this assembly is made, it's such complicated, like turbine is installed here and pump installed here, and not like we did in our previous cases, pump here and turbine here.